So today we are here to discuss about NIST Special Publication 800-207 given by the as a standard on the zero trust architecture. So it is like not as a standard basically. Fine, this is more of a guideline, more of a a architecture document which defines what is zero trust. I'm Rahul Kokcha. I'm the secretary for ISC to Delhi chapter, and we are running this as a community work. And many of you are the already member of the ISC to Delhi chapter, and this kind of learning sessions will organize. We target to conduct a physical event also, maybe during about the end of next month. We'll have a physical event as well in Delhi NCR. So, but you will get the details of the next session, which will be online, and the next physical meeting, which will be towards the end of next month, and through our LinkedIn page as well as through our groups. So let's begin with the discussion on the NIST SP 80207, which talks about the zero trust architecture. So zero trust is basically it's just a concept, right? Not even a kind of it doesn't define anything specifically that which tool we can use, right? So there is no, it only has the principles. It's only a concept, and not even the principles. They call it as tenets, which means the pillars. So it has the seven principles, right? And why we are going towards the zero trust is because these days, if you look at the networks are no longer, the people are no longer on the corporate network only, right? Our resources are in the cloud, our people are roaming. So that's why we can no longer trust the concept of being in a local network, being in a corporate network. Even if we are in the corporate network, and if one machine gets compromised, the lateral movement for the ransomware, for the malware, for the attack vectors, right, that becomes very easy if we are trusting people, trusting devices and people over the network without further controls. So that zero trust says that we have to move the controls towards the resources that we are hosting rather than focusing on the network architecture, right? So in zero trust architecture, we are not basically trying to impose controls on a DLB and the firewall IDS IPS. We are trying to put controls closer to the resources where even if the systems or the network are compromised, if I'm checking all connections locally on my machine on at the resource level, then even if the network is compromised, my resource will be protected. That's the concept of zero trust. So I said these days, no network you will find, no corporate you will find which doesn't have the people working remotely. And many of the corporates are already moved to the cloud. Fine. So most of people are using Microsoft 365 at least, and or some of the other cloud services. So resources as well as people are no longer on the local network, on the corporate network. So that's how the implementation of zero trust becomes more important, because we are no longer the people working remotely, they are no longer on the secure network. So we cannot trust the network they're connecting from. They might be sitting in a coffee shop, maybe on the airport, maybe at a home network. Same way, the cloud services are our resources, which is hosted out of my corporate network. So the idea is to move the controls. Fine. If you look at the legacy systems, in the legacy system, the controls were towards the perimeter of the network. Fine. We had the firewall and the IDS and IPS. Fine. So we are talking about now move the security controls to at the resource level. Fine. Not at the network level, but at the resource level. That's the concept of zero trust. And this zero trust architecture assumes that the attack has already happened and the attacker is already on the network, and it believes that we have to protect the network not the network, protect the resources in a way that we assume that there's already the systems are already compromised. Right? There's a famous statement from the ex-CEO of Cisco as well, that there are only two types of organizations: one who already compromised, who are already breached, and those who don't know. Fine. So it is following the same concept that there is no organization which may say that I am 100% secure. Right. So we should not no longer rely on the security of the network. We should try to protect our resources. And when it comes to zero trust, there's like the terminology they use is a subject and the resource. Fine. And subject is any party, which is maybe a human or maybe a service, maybe a API, which is trying to access a resource. Right. While a resource is any object which is being accessed. Fine. So if you look, if many of you are from the CSS, we have done the CSSP and understand the CSSP terminology as well. So in the CISSP, it talks about the subject and the object. Fine. While it is here, it is talking about the subject and the resource. Fine. The object is the resource here, basically. So it talks about that we have the subjects, we have the resources, and we have to look into the transactional relationship of the subjects and the resources. And that transitional relationship has to go through a kind of a policy enforcement system, and means a kind of security control in between the subject and the object, where every transaction will pass through this control, and every single session need to be validated. Right. Look into more details in the next slide for the same thing. So what we check at this checkpoint is fine. So this sorry. So at this is called as basically a combination of a PEP and PDP. We'll discuss in detail what the PEP and PDP is in the coming slides. In terms of the CSSP, you can understand this as your security kernel. Fine. So those who have done the CSSP, if you remember what the security kernel was, the security kernel controls the access by the subjects to the objects. Fine. Every single the transaction has to pass through the security kernel. That's the same concept we have applied here. But here it is called as a PDP and PEP, right? So we'll discuss in detail what the PDP and PEP is in the coming slides. But the checks, what we need to do is we validate the identity. Means user authentication is still important. We are validating the user identity, but not only the user identity, we are also validating the system health. Means whether the system is patched, whether the system has antivirus, those checks we can control, we can check. And it is similar to like if we have implementing a NAC on the network, fine. So which checks the device health before allowing the system to communicate over the network. So that is the same concept we apply here. There is no single product in the market which is complete, which can completely implement the zero trust architecture in any organization. Right? So zero trust architecture is still in a conceptual phase. And even the standard NIST standard also talks about that this is this is a migration. We are into the transition phase basically. Fine, we are migrating from the legacy network to the zero trust architecture, but there's a long way to go. So what we check is the identity. What we check is the system. Fine. So we are checking the user. We are checking the system through which he is connecting, and also we are checking the behavior of the user. Means whether he is connecting to the right set of IP addresses. How come a person is in India and at the same time he's trying to log in from the US as well? So that type of behavior also it checks, and also the time of the day. Fine, and many other parameters as per the use case of we can implement. Then when it has a sufficient confidence level that this request is legitimate, then only this policy enforcement point allows the subject to access the resource. So, and as it said, like zero trust is architecture is a journey. It is not a kind of a replacing the devices and we'll get to the zero trust architecture. Fine. So we are still in a very initial phase of zero trust. Fine. And for a long time, you will remain in this mode only. Fine. Because there is no clear kind of a feasibility, fine, of implementing zero trust to the 100%. Fine. So there are a few things which will still left. So you have to migrate slowly from the legacy network to the zero trust architecture. So again, so mostly organizations, what we can foresee in the future is like we have the hybrid of the zero trust as well as the legacy network, right? So means the both will stay, and we will end up in creating a hybrid network depending upon the risk factors and the risk assessment, and the risk tolerance, and the organizations will adopt the zero trust principles while they are implementing their network components. Then there's 7 tenets of zero trust. And so what is zero trust? This is the slide. Find what is zero trust and what what makes our network as a zero trust compliant. So there are the 7 tenets. One is like the data sources are all the basically resources. Fine, are basically like any data, any system, any application. What is important for us is called as a resource here, as it is called as an object in the by the CISSP book. The all communication need to be secured. Fine. We have to validate all sessions. Fine. Probably we can go to the next slide because they will talk about these tenets in detail. So if you look at the first tenet, that all computing resources are the resources which we need to protect. Then all communication, whether it is internal or it is external, whether it is a remote access, whether it is a local, fine. So it has to be kind of protected or means kind of encrypted. HTTPS or similar technology need to be used. Then we need to grant access on per session basis. Means this is if you look at the Active Directory, fine. So Active Directory has some component of zero trust already. So there's a features already in place. So in the Active Directory, we authenticate the domain controller, and then we get a session ticket to access a particular application server. Fine. If you want to access another application server, you need to again go to the domain controller and get a session ticket for the second system as well. Fine. So this is the same concept here as well. So means for every session you're establishing with the same subject and the different resources, or the same subject with the same resource as well. Fine. If it is a different session, it has to validate the session again. Validation will involve again the authentication of the user, validation of the system, and looking at the behavior analysis and threat intelligence. Then access is determined by the dynamic policy, which talks about like that we can incorporate the threat intelligence, and we can provide that information. Maybe this is attacking IP, so which my system should not allow the access to. When all that information can be integrated into the zero trust architecture. And if you look at the basic rules, like what's the time of day, what is the normal user working hours, find what is the normal user location, find whether is it possible that user can move from one location to another IP address, find in short time, find based on the geographical locations. So all those things can be checked. And dynamic policy means because these factors will keep changing, and that's why the decision by the zero trust architecture security control will also keep changing. And for every single session, every single request, the authentication authorization has to be strictly enforced before we can grant the access. Then all access need to be monitored. Fine. And when we monitor, like we are monitoring for the security postures of the system. Fine. And the kind of we are also trying to collect the data so that we can log all this information, and so that we can do the analysis, and we can also generate the intelligence out of it. So these are 7 tenets. Fine. And again, the concept is same, that the network is we are considering that we are already operating in a compromised environment, and so we are no longer secure. So we have to believe that that there's no security other than what I can apply at the resource level. So we are not assuming like whether the user is coming with his own device on the BYOD environment, or whether user is accessing cloud resource where we have we can apply limited controls. Means we cannot apply for the SaaS applications, we cannot apply many of the controls, right? Depending on what type of cloud architecture we are using. So if we have the limitations of applying the control to the cloud services, then we do not trust any network. Fine. We consider that the attacker is already present, and the devices might not be owned by the organization, and the credentials might be stolen. Fine. Means the user account might have already been compromised. Then not all the sources are on the enterprise network. So we have the cloud services, and many of the people are working remotely. So in the remotely, they are connecting through the network, which is not owned by the organization. So we cannot trust that network. And the assets might be moving from the corporate network to the home network. And we cannot rely on the security controls on the corporate network only. So the security control should also move as the assets are moving between the networks. Then zero trust is a approach, fine, and there is a long way to go to moving from legacy architecture to the more granular controls at the resource level that implements the zero trust architecture. So the logical components we see, this is exactly same as what we used to study during the CSSP days as a security kernel and reference monitor. Subject and the object. So there is a security kernel in between, fine. And the security kernel talks with the reference monitor. If you remember the CSSP, fine. The security kernel talks to the reference monitor to decide whether this connection can be allowed or this session can be allowed or not. Fine. The same concept is applied here as well. So the policy enforcement point is a security control. Well, the policy decision point is a kind of a is a brain of the of the control, means someone who is making a decision whether this session should be allowed or not allowed. Fine. So all the intelligence are coming to the policy decision point basically, and it is enforced through the policy enforcement point. Means every single access request to the object of the resources should be made through the policy enforcement point only. Fine. And the policy enforcement point can be because it is receiving the traffic. Fine. Somebody can play with that. And so it is not making decisions on its own. It is the decision making component is separated from it so that somebody cannot influence the decision. So this is only the kind of a control point which will say whether access can be allowed or not allowed. Fine. Similar to your firewall. But we are not talking about the network here. Fine. We are talking about the session level validation here. So this DP is consists of two components, but is a policy engine, and the policy administrator. Fine. Policy engine is actually which makes all the decisions, and the policy administrator is a component which passes that decision to the policy enforcement point. So a subject here will access an object through the policy enforcement point, which will get instructions from the policy administrator, which will get the further the instruction, the decisions from the policy engine. So even if somebody tries to compromise this, so there are two layers of this decision making here. So means making it more difficult to compromise it as well. Then whenever we receive a request, we check the subjects, we check the assets, whether the assets are correct or not. The checks we want to make, for example, the assets what we have should if it is a part of a domain, then it should be part of a domain. The machine should not be like any BYOD machine cannot be allowed in that case. So the subjects and assets are validated. Then we check the policy whether BYOD is allowed, means a system outside network can access the entire resource or can access the part of the resource. And that type of checks we can make. And then we also get the threat intelligence fed into the policy engine. So which also helps policy engine make decision whether this is a legitimate request or this may be an attack. So based on these checks, we either allow the access or deny the access. Then zero trust architecture use cases. So there are like these 5 use cases given in this NIST standard. Right. So there may be like the remote branch offices where connections coming from the remote branch offices can utilize the zero trust. Multi-cloud environment can also utilize the zero trust. Fine. We'll see the details in the coming slides. I'm just skipping this then. Okay. So again, it talks about that this is a transition phase, and from the legacy perimeter to coming to the zero trust architecture, there is a long way to go. Fine. And we cannot just replace the piece of technology to build the zero trust architecture. So first, scenario is that when we have the remote workers, traditionally we have been allowing the people to connect to VPN to our corporate network, even if they want to access the internet. So we want the traffic to go through our corporate network because so that our firewall filtrations firewall rules can apply for the remote user as well. But if we have the zero trust architecture, you don't need to route your traffic, fine, from internet, the users coming from internet to your organization, and then again allowing then you are connecting him to access internet resource through your network. So you can save the bandwidth, save the resources by allowing this user directly to connect to the cloud services without passing through your corporate network. Fine. So that's the concept here. So this is scenario 1, where we can use a zero trust architecture. Second is if we have the 2 applications hosted in 2 different clouds. And again, to connect those different clouds, we are using corporate network, and we make a VPN connection between any other secure connection between the cloud and the enterprise network. And then from our enterprise network, we are connecting the cloud the cloud resource on the second service provider. So in this case also, we can directly make a connection instead of passing the traffic through a corporate network if we implement a zero trust architecture. So in this you can take an example of we have the Airtable as a database. Fine, Airtable is a cloud-based database service where we can we can host our a simple Excel kind of sheets, as also can use it as a database. Fine. So there are kind of applications which can connect directly to the Airtable as well. Fine. So through the APIs and all. So that traffic can be sent from one cloud application to the another cloud application directly without allowing it to pass through our enterprise network to have a control over the internet over the corporate network. Then coming to the third case, when we have the visitors and the means external people coming to the organization. So visitors do not need to have the access to the your enterprise resources. So they can just directly access. They can just be connected to internet access. So most of the organizations has the separate guest Wi-Fi these days, fine. So which does not connect to the corporate network, but this only allows the guest to access the internet. So this is already in place. We have. So, but the technicians and the contractors who are coming to the network, when they can join our internal network, they get access to they can see all the system of the network. So data also says that if a resource is sorry, if a subject is not trusted, or till the subject is trusted, so when he should not be able to see the resources on the network itself. Means if a subject is being allowed to access a particular resource one, he will not be able to see any of the resource on the network. Well, that's the concept of trust architecture. He should not be able to even scan the network. He should not be able to perform the reconnaissance. Fine. He should not even know that how many resources, how many systems, how many IPs are live. Fine. So anyone who joins the network can see the network traffic. Fine. Or can just kind of ping the different systems currently in our corporate networks. If there is a contractor coming to us, maybe just to conduct an audit, for example. So he is bringing his system. If you're allowing his system to connect to the network, he can use that system to reach out to your multiple machines. Maybe he will not have the user authentication, and user authentication may be blocked. And by creating a VLAN, we are trying to reduce that scope that what he can access. Right? But in the zero trust architecture, we are not even relying on the VPNs and the VLANs. Right? It says that only one resource, which is allowed by the contractor, by the visitor, by this guest. Fine. So only that resource should be visible. Other resource should not be visible even. So if this contractor is allowed to access only this HVAC system, he can access only HVAC system. He will not be able to see the enterprise systems, networks, and applications. Then the scenario 4, when we can have the two organizations collaborating. For example, when you go for acquisitions and mergers, you may have a users in one organization, resource in another organization. So we create a domain trust basically, fine. So when we create a domain trust, or the federated identities, fine. So we create a federation between the domains, fine. Then we can allow the users from the one organization to access the resource in another organization, fine. So that is also they are accepting that this is also one of the valid way of implementing zero trust. And but the thing here is, if we are allowing the user in the other domain to access this particular resource, he should not be able to see any other resource. And that's the concept here. Then coming to the scenarios where people are accessing cloud services, and the browser-based access is being made, where you cannot validate which system the user is using. Fine. So the subject is using. So in this case, they understand that there's a limitation of implementing all the tenets of zero trust. Fine. So we may not be able to validate the system. Fine. So in that scenario, we will just validate the user. Fine. And we'll validate the behavior. Fine. Means the system cannot be validated. Whether system has an antivirus, system has a patch, the latest patches or not, that can be validated. But rest of the component, we should still validate what we can, because the user will have a behavior. Fine. Again, user coming from one IP, another IP, all those things we can still check. And based on that, if traffic is legitimate, we will grant access to the service. Otherwise, we will not. Then zero trust, it's looks very fancy and looks very like robust that if we implement all these principles, all these tenets of the zero trust architecture, then probably our network will be, our resources, not the network, resources will be very secure. So some people define the zero trust architecture as zero trust network architecture as well, ZTNA. Right? So this is not a ZTNA because we are not talking about network here at all. We're talking about putting the security controls at the resource level, moving away from the network level. Fine. So ZTNA becomes like a kind of a inaccurate word then. Fine. So it should be zero trust architecture, not zero trust network architecture. So, but yes, whenever we implement the zero trust architecture, it looks like that we are trying to like implement the security controls to the in the best of the best of the abilities. But the zero trust itself has certain risks. Fine. That has also been acknowledged in the NIST standard. Then enterprises cannot eliminate the all the cybersecurity risk, fine, even with the zero trust, because the zero trust is also a piece of software or piece of like kind of a control which can fail and which can be compromised, fine, which can be targeted. So in case of zero trust, what if somebody try to attack the zero trust itself? Fine, because now the entire decision making is at the zero trust as controls. Fine. So what if somebody tried to compromise the zero trust architecture? So the all the controls you have implemented to implement the zero trust, if that solution is being compromised, then the entire access, entire system, entire network is compromised. Similar to like we have access to firewall, if we have access to domain controller as the administrator, fine, then you can access any resource in the network. Fine. Same way, if the zero trust is compromised, then probably you'll have the access to the entire network depending upon the like where all the solutions is implemented and what and how far one can go by compromising which part of the zero trust architecture. But yes, the risk is still there. Fine, the risk cannot be eliminated. The risk cannot be simply if zero trust doesn't make the enterprise as a zero risk enterprise. Then what if somebody try to brute force or somebody try to like kind of flood the zero trust decision making point or the policy enforcement point that it shall not be able to make the decisions, fine, or maybe because you cannot have the direct access without going through the your policy enforcement point or the zero trust solution. So what if somebody flood the zero trust solution so that zero trust solution is not able to make any decision or grant any access, so your entire network can be blocked. Entire the sources, all the resources in the on your corporate enterprise network will be unusable. That's a denial of service here. Then in the when we are using cloud-based services, fine. So in that scenario, one can steal the identities. Fine. If they are able to steal the identities, then because we are not able to validate the system here, from which system the user is coming, and if you're allowing the BYOD, fine. In that case also, if your system, the system what somebody brings, fine, is because that system is no longer part of a domain, so we are not checking whether the system is a corporate asset or not. Fine, we are only checking whether the system has the antivirus and the patching. Fine, or what time of day and all of the things that we are checking. Fine, so if the system is not a kind of a trusted resource, we are allowing the BYOD kind of thing. In that case, if the user account is compromised, still the same situation arises that only based on the user account compromise also the one can access the network or the resource body. Then the zero trust architecture, because we talk about the all the network should always be encrypted. Fine. So means the entire network traffic is encrypted. So if we have the entire network traffic encrypted, in that case, we cannot inspect the traffic also, what is going on. So we that creates a blind spot basically. Entire network. So means we cannot have the IDS, IPS in this kind of environment, fine, which is inspecting the traffic and raising alert. So it's everything we are relying on 100% on the zero trust only, on the zero trust solution only. Fine. So we are not we can no longer inspect do any inspection based on the traffic because the traffic is encrypted as per zero trust tenets. Then because zero trust talks about that we need to log everything, fine. So all these logs can also need to be protected with using the same zero trust principles. Otherwise, these logs will become the channel of reconnaissance, because using that in the logs, you can see what all IP addresses and all the like the patterns of the access and all is there. Fine. So if one can access the log of the zero trust solution, then also you will be able to perform the reconnaissance of the on the corporate network. So that also need to be protected and with the same level of controls. Then because zero trust solutions are, there are many like vendors which claim to have the zero trust architecture, fine. So but the organization need to be careful when they are selecting the zero trust architecture solutions, because you might end up in the locked in into that vendor particularly, fine. Because the zero trust is a new concept and people will have a different way to implement it. There's no common standard for implementing a zero trust solution. So you may end up that if you pick up a solution from one particular vendor, that you're locked into that particular vendor solution only, and because it may become difficult for you to migrate from one network to another network. So that's also is a risk of like a kind of a it's an operational risk basically, fine, that you can end up in the with the same solutions, and that solutions may be good today and maybe some other solutions are uh, maybe innovating in a better way and providing more better security, or maybe you end up you bring up a new application, new server, which particular solution doesn't support well, fine. So and there may be other solutions in the market which are supporting that application, fine. So that type of issues can arise with the zero trust. This is all being accepted in the NIST standard. Fine. There's nothing that we have created from somewhere else. This is all taken from the NIST standard, this 800-207. Then when you talk about the compromise of the user account, so with the human entities, it's become very easy because you can have the two-factor authentication implemented. But with the the kind of the service accounts, the accounts which are used by your applications, APIs, trying to access the resources, those becomes the non-person entities. So non-person entities, there's a limitation of applying this MFA, like two-factor authentication based on the passports and all. Fine, that becomes a limitation. So what if so that this will still remain if there is a like authentication between the APIs, which is based on the certain string, certain credentials. Fine. So that will still remain. That this will still remain. That because you may not have the OTP based authentication or biometric based authentication in that particular scenario. So this will still be this to the zero trust architecture. This cannot be eliminated. There are solutions for this, but the solution itself is again piece of software, and every piece of software has some vulnerabilities, or add some vulnerabilities to your environment. So there always means that this cannot be eliminated basically. So zero trust is again a journey, and we cannot simply just implement it, because with the environment, as the environment is changing, the zero trust will also change. Right. So this is not that we just implement it today and whatever the efforts we have made today, that will apply for a long time, because the business does not remain static. Right. So this business does not run, and business does not run in straight line. So there's always a deviations, always new technologies, new use cases which will appear. So that accommodation that will need to be accommodated in the zero trust architecture as well. So that has to be planned well before we can enforce the zero trust principles. Then when it comes to deployment, so we should deploy the zero trust as we deploy the DLPs in the organizations, that we put the DLP in the read only, in the reporting only mode, find only monitoring only mode. Find same way we should deploy the zero trust also in a reporting only mode, so that the zero trust architecture can learn the patterns, fine, before we can start imposing or enforcing the restrictions. So it need to be put in the observation mode or the reporting only mode, so that it can learn, because zero trust is talking a lot about the behavior analysis. When depending on the solution you pick, it's not talking about any particular solution. When depending on the solution you pick, that solution may require its own time to learn from the environment. And based on that, like what are the components they are, what are the parameters they are using to make that dynamic policy decisions. And it may be traffic pattern, it may be time of day, it may be different kinds of user accessing these applications normally, why the user is trying to access some other component of the, or maybe a user with a normal access. Fine, why it is trying to all of a sudden what is trying to get to the admin access. Fine, might be he's promoted. Fine, might be he got some additional responsibilities. Fine, so what this solution is learning. Fine, that we have to figure out, and there may be always a learning requirement. Fine, as the business is changing, and so we cannot simply put and enforce any zero trust solution into the network. It will take its own time to learn before we can impose the restrictions. Then after putting into this learning mode, we need to adjust, fine tune the solution so that we can go with the we limit the we are able to reduce that kind of the failures of the or maybe the wrong decisions of false positives. Fine, so that the legitimate access is not blocked, and only the attacking or a non-legitimate access is blocked. Fine, so that will take again time. So we need to fine tune, and not only initially but with time also. Then once also pick up basically pick up the small set of the source which is least important for the organization. Fine, try to stabilize the zero trust solution with that solution. Fine, which and first the resource should be using the should be the least important, and also it should have the minimum impact on the number of users. Fine, so the number of users should be impacted by any if it is not able to work, if it is not working well, if it blocks the access, that should not have the significant impact on the business. So try to stabilize that. And once it is gets stable, if we are confident, yes, it is making the right decisions, then try to expand the scope of the zero trust implementation. Don't simply jump to the implementing zero trust implementation, like a zero trust implementation onto the most critical assets. Right? That will be that may be that may become a disaster. Then zero trust is living architecture. So it is not just a fit and go kind of solution. So the new devices require updates, fine, and same way the organization structure may change, needs may change, people role may change, and there may also be the updates to the softwares of the resources, fine, also which changes the pattern, and also the update may be in the zero trust software as well. Means it will add new features or new way of functioning. So that may also need to be again further stabilized. So it's a long way to go. It's not easy that you can just implement a solution and buy a solution and implement it. So zero trust is still a concept, right? It is a kind of so why all of a sudden from the in the recent few years we're talking about the zero trust is because in 2020 basically the NIST has released the standard. Right? Before that it was introduced in somewhere in maybe I think in somewhere in 2005, I think it was introduced by some of the everything was done by the DoD only. Fine, so it has come to this level in 4 phases basically. Fine, that history is also given in the standard. Fine, that you can refer to the standard. NIST standards are free. You can download and refer to it. So that in 2020 this NIST was released. Fine, NIST 8.207 was released, and that's how the zero trust is being been talks from since then only. And so zero trust is still a concept. Fine, it's still in a very initial phase. Fine, we are not able to replace that, and we cannot replace the existing technology, existing environment. Fine, just to go to zero trust, we have to see out of 7 tenets how many we can implement. In some scenarios, in some use cases, we can implement more. In some use cases, we can implement maybe 1 or 2 only. Fine. So, try to the concept is that try to follow the zero trust architecture. Keep in mind whenever you're designing the network, designing the security controls, so that slowly and gradually we are able to mature the practice of the zero trust architecture in our organization. Thank you. So this was all about the zero trust architecture. I recommend everyone to read the NIST 800-207 standard. Fine, and we are open to questions now. You can post your questions in the chat box, and I'll be here to answer it.